Welcome to our help video on 4-12 doing electron configurations. Remember, electron configurations are a shortened version of doing orbital notations. It is essentially an orbital notation without all the orbitals and the arrows. When you're doing electron configurations, it's very useful to have with you an off-file order of filling table, such as this one right here. We have this in our notes. This is part of our 4-11 notes. And this is a very useful thing to help you keep track of whether or not you're doing the electron configuration correctly. Once again, an electron configuration is one of the four types of electron configurations we are learning. The first one was orbital notation. That's an electron configuration. Then we learned to do electron configurations, which we're doing now. And then later this unit, we'll learn to do two others. The first one we're asked to do is an electron configuration for potassium. And they gave us the atomic number 19. So to do this, we'll just go to our off-file order of filling right here. This is the one, off-file order of filling, and it's on the off-file tab on Google Classroom. When you open this, you'll see it right here. It's not the tab here. It's not the first tab. That's the periodic table quantum number periodic table. This is the off-file order of filling. So make sure you're clicking on the correct tab here. And we continue on. Potassium is right here. If you see potassium is right here, K19, and we can see that it is in the S block. This is the S block right here. These two columns are the S block, and potassium is the first element on this row. It is in the 4s1, which means when we look at its electron configuration, it should end in 4s1. Really, you can come right out to the right and write 4s1 right now. That's where it should end. And then we're just going to go through the steps to getting to 4s1. So if we look right here on the periodic table, to get to right here, we have to go through the 1s. How many elements are on the 1s? There are two, hydrogen and helium. So we'll start off with 1s2. There it is, 1s2. And we are finished with this first row. Then we'll bounce down to the second row of the periodic table, and that begins with the 2s. Once again, this is the S block. This will begin with the 2s. How many elements are there? 2, lithium and beryllium. So it's 2s2 is next. There's two elements in the 2s. So we would then write 2s2. Now we're going to continue moving left to right. So after the 2s, we come to right here. This is the P block. So this is the P sublevel. What's the number associated with it? It is a 2. The 2 goes right across, right to there. That 2 goes with the 2p. There is 1, 2, 3, 4, 5, 6 elements in the 2p. So we would write 2p6. We are now finished with that row. And we'll come down to the 3. Here's the 3. This is the 3s. How many elements are in the 3s? 2, sodium and magnesium. So we will write 3s2. We're continuing working our way to potassium, K19. But to get there, we've got to proceed over to here, and we will find this sublevel right here. Once again, this is the P block. So this is the 3P. How many elements are there? 1, 2, 3, 4, 5. I'm counting 6. So I will write 3P6. And now I am on the row with potassium. There's potassium right here. I'm on the potassium's row. It is the first one in the 4s, so I will write 4s1. Now to double check to make sure I did this correctly, I already matched the coordinates on the periodic table. Fourth row, S block, first column. So this is the row, this is the block we would find it in, and this is the column. 4s1. 4, it is in the S1. 4s1, those are coordinates. The vertical coordinates are in the S. The horizontal coordinates are in the 4. 4s1. Now the next double check is to make sure I didn't mess up. There should be an atomic number of 19. That means there's 19 protons. Therefore, there should be 19 electrons. So we count them up. 2 and 2 is 4, and 6 is 10, and 2 is 12, and 6 is 18, and 1 is 19. Next question, how many valence electrons does potassium have? Valence electrons are electrons in the outermost energy level. In other words, the largest N value. N is my first number right here. That's my N value. That is the number is right here. These are the N's. That is the N value. So the largest N is where I will find the valence electrons. So for potassium, that's a 1. Nope. There's a 2. There's a 2. There's a 3. There's a 3. 4 is my largest number. So that is my valence level. And there's only 1 electron in there. So my valence electrons are 1. Next question is, what is the Roman numeral above sodium or above potassium? Here's potassium. I go straight up. There's my Roman numeral right here, Roman numeral 1, as well as it should be. The Roman numerals for the main block families should line up. And the main block families are the ones that the N lines up with. That's the S and the P's. So for the S and P block, the Roman numerals should always match the valence electrons. The next one, nickel 28. I've got to find nickel 28 on the periodic table. I did. There's nickel 28, and above nickel 28 is an S2D8. So if I did this right, I'm showing you where I got that S2D8. There's nickel. There's the S2D8 above it. Nickel has 28 for its atomic number. So nickel should end in an S2D8. And it did, and I can write that right now. It should end in an S2D8 if I do it correctly. All right, let's go ahead and start nickel. We'll start at our very first sublevel. Our very first sublevel is the 1s. How many elements are in the 1s? There are 2. So I'll start with 1s2. That finishes off the first row, 1s2. You're like, what's this over here then? That's still the 1s2. Hydrogen and helium sometimes can be put over there, or they can sometimes be put over here depending on what you're looking at. But there are, in either case, there's 2 elements on the first level, hydrogen and helium. Second sublevel I come to is the 2s. That has 2 elements, lithium and beryllium. So I write 2s2. I can continue over on the second row of the periodic table of elements, and I come to the 2p. 2p. See, it says right in there, 2p. 2p. 1, 2, 3, 4, 5, 6 elements are in the 2p. There they are, 2p6. I'm finished with that row. I now come to the 3s. There's the 3s. That's next. Sodium and magnesium are there. The 3s holds 2. So I write 3s2. I continue over to the next part of the periodic table. This is the 3p. You see the 3p written right in there. And there's 1, 2, 3, 4, 5, 6 elements in the 3p. That finishes off that row. Now I bounce down to the 4s. There's the 4s. That must be next according to Aufbau. How many elements are there? There's 2. So I'll write 4s2. What comes next? It looks like after the 4s, from number 20, I go to 21, and that's taking me into the 3d. So I write 3d. And now I'm going to count how far over it is in the 3d. Nickel is 1, 2, 3, 4, 5, 6, 7, 8th one over in the 3d. So I'll write 3d8. It is 3d8. I have done nickel. And yes, I have the S2D8 as predicted above nickel S2D8. Next question I'm asked, how do I know I did it right? Well, one way, I have the S2 and D8. The other way, add up the electrons. 2 and 6 is 10, and 2 is 12, and 6 is 18, 20, 28. So I know I have the right number of electrons. Now it's asking for valence electrons. Once again, valence electrons are electrons in the outermost energy level. In other words, the biggest N. I see a 1, a 2, a 2, a 3, a 3, a 4, and back to 3. Oh, why does it go back to 3 again? Aufbau order of filling. The 3D has an energy of 5. Where do I get that? When you're in the D. When you're in the D sublevel or D block, the energy is 2. So my second number, the L, is 2. What is my N when I'm there? My n is the first number, 3. So 3 plus 2 is 5. The 4s only has an energy of 4. 4 goes there for the 4s. What's my energy in the s? S is 0. The second number is a 0. So I add a 4 and 0 and get a 4. So these are the second number values. When you're in the S, your second number is a 0. When you're a P, the second number is a 1. When you're a D, the second number is a 2. And the F, your second number is a 3. So my second number is a 2 in the 3D. My first number is a 3. 3 plus 2 is 5. That is a bigger number than 4. That's why it gets filled after it. All right. Back to the question at hand. My biggest number here is a 4. There's 2 electrons in the 4s, so my valence electrons are 2. Note, the main block families, the 1 and the 2, and this 3, 4, 5, 6, 7, 8, the ones that are on this line right here, are telling you how many valence electrons they have. That's what they're telling you. The S and the P are the main blocks of the periodic table. Those are the parts of the table that the numbers line up exactly. That's the 1s, 2s, 2p, 3s, 3p. Those are the main blocks. When they line up exactly, the Roman numerals tell you how many valence electrons there are. For nickel, the Roman numeral is 8. That is not telling you how many valence electrons it has. It's really not telling you anything substantial other than the fact that there's an 8 here and an 8 here. Why do all three of these have 8? Because all three of these have similar behaviors. So they've kind of lumped them into the Roman numeral 8 block. So these numbers are telling you different things than these numbers. These Roman numerals on top are telling you how many valence electrons they have. Here they're telling you something different. This 3 is telling you how many electrons the elements in that column have in the S and the D. 2 and 1 is 3. 2 and 2 is 4. 2 and 3 is 5. 1 and 5 is 6. 2 and 5 is 7. These three are all behaving the same. 2 and 6 is 8. But cobalt behaves like that guy. Cobalt behaves like iron. Iron gets the 8. Nickel behaves like cobalt and iron. It gets the 8. And then they go back to 1 here. Why do they go back to 1 here? It's because copper has now filled the D. So there's no use in telling you how many are in their D anymore. Copper has 1 in the S, 2 in the D, 10 in the D. So that 1's telling you that. Zinc has 2 in the S, 10 in the D. The D's full. The D only holds 10. So there's no use in telling you that with Roman numerals anymore. We're going to stop the help video right here with these first 2 questions. And we will pick up on the next help video with the numbers that will follow.